Hello, algebra. Welcome back. I'm going to talk to you about perpendicular lines. So here we have a green and a blue line, and they are perpendicular. Let me tell you about why that is. This angle here is 90 degrees, and that's what it means for two lines to be perpendicular. So perpendicular line, oh my gosh, my handwriting. Perpendicular lines intersect once at a 90-degree angle. So perpendicular lines are like the lines on this page always intersect. If they intersect at a perpendicular point only once. In fact, the x and y axis are perpendicular to each other. They intersect at a 90-degree angle. So let's figure out what the equations for these lines are, because there's also an interesting equation. If you look at the equation, if you look at the lines graphed, you can see, yeah, these lines look perpendicular to me. There's a way you can verify it using the equations. So let's look at our green line first, and let's find the y-intercept. The y-intercept of this green line is right here. So that is the point 0, -2. And let's figure out what the slope is. Here's another point on my graph. So if I do +2 in the y direction and +3 in the x direction, that gets me to my next point. So my slope is equal to a +2 change in y over a +3 change in x. So I can actually use my formula here, y equals mx plus b, to say the equation of this line is y equals 2/3 x minus 2. So that's the equation of our green line. Let's do the same thing for our blue line. Let's find first the y-intercept. That's this guy right here. And to me, that looks like the point 0, 3. And we want to go to this next point and calculate what the slope is. So the change in the y direction is negative. I can see I'm going down 3 and then +2. So for our blue line, our intercept was 0, 3, and our slope was a -3 in the y direction and a +2 in the x direction. So our equation is y equals -3/2 x plus 3. So that was our blue line. This is our green line, and these are perpendicular lines. So what the thing I want you to notice is these slopes actually have a relationship to each other. These slopes are what we call negative reciprocals. -3/2 and 2/3 are negative reciprocals. So what that means is if I take -3/2 and I switch the numerator and denominator, that gives me 2/-3. Then I switch the sign, and that gives me 2/3. So if I start with -3/2 and I take the negative reciprocal, I get to 2/3. Same thing with 2/3. Let's say I have 2/3. So first I take the reciprocal, I switch the numerator and denominator. That gives me 3/2. Then I switch the sign. Instead of +3/2, I make it -3/2. Right? So these are negative reciprocals of each other. Another way to check negative reciprocals is the product of negative reciprocals is always -1. So if I take 2 over 3 and I multiply it by -3 over 2, using my rules for multiplying fractions, the numerator is multiplied by the numerator, 2 times -3. And the denominator is multiplied by the denominator. That gives me 3 times 2. I have common factors of 2 that I can eliminate and common factors of 3. The only thing left is that negative sign. And so then my answer would be -1. So let me show you the most common thing that comes up when you're doing homework. Is they'll say, they'll ask you, let's do 2 examples. We'll do one of a slightly easier variety and one that's a lot of work, but once you get the hang of it, not so bad. So let's say our y equals 2x plus 3 and y equals -1/2 x minus 2 parallel, perpendicular, or neither. And that's what you have to figure out. So you have to remember for parallel lines, have the same slope. And 2 is not the same as -1/2, so they are not parallel. And then let's go ahead and check if they're perpendicular or not. Now we want to know if they're perpendicular or not. Slope of perpendicular lines are negative reciprocals. So let's check that. So if I take 2 and I multiply it by -1/2, that's the same as saying 2 over 1 times -1/2. And so here I have common factors of 2, and I'm left with -1 over 1, which is -1. So these are negative reciprocals. So yes, they are perpendicular. Ooh, I ran out of room. But you know what I mean. They are perpendicular. And the second most common example you're going to see is they're going to say, write the equation of a line perpendicular to y equals negative, let's say 1/3 x plus 2, passing through the point 2,7, let's say. So right away, we want to be thinking of this equation of a line, which is called the point slope equation. And the reason we're thinking about that is we say, look, we already have this point. Well, let's not use red. We've been using that for slope. We already have this point 2,7, so I know what to put in for y1 and x1. But the trick comes about m. What do we put in for m? The slope of this line is negative 1/3, but we don't want to have the same slope. Same slope would give us a parallel line, and we want a line that's perpendicular. So what we want to do is take the negative reciprocal of negative 1/3 x. So our m should be the negative reciprocal of negative 1/3 x. So first we take the reciprocal and flip the fraction over. Then we take the opposite sign. We have negative 1/3 x, so instead we want this one to be positive. And then I always check my work. I say check, and I take 3 times negative 1/3, and if I do that out, I do get negative 1, so I know I'm good. So this is the slope my line should have. And then I'm ready to plug in here. I would say y minus 7 equals 3 times x plus 2. Oops, not plus 2, minus 2. And then I go ahead and put this into slope-intercept form by distributing my 3. Y minus 7 equals 3x minus 6. And then I add 7 to each side. And I get y is equal to 3x plus 1. I know I go quick in these videos. If you need to watch it more than once or you need to replay a few seconds, that's great in my opinion. It's just hard for me to go slow when I don't have your beautiful shining faces asking me questions. Okay? So don't feel shy. Watch it more than once. You repeat the video. Do what you need.